In this video, we are learning a very important integration technique called integration by parts. This method is useful when we multiply two functions and cannot integrate directly. Topic: integration by parts. Now, we already know how to integrate basic functions like polynomials, exponentials, and trigonometry functions. But what if we have something like x multiplied by e raised to the power x, or x multiplied by ln x? These are products, and normal integration rules don't work easily. What do I mean? If we have integral x e raised to the power of x dx, or integral x ln x dx, we have this problem. The normal integration rules don't work easily to solve this problem. Integration by parts comes from the product rule of differentiation. From this product rule, we have to use integration by parts. Let's look at the formula. Integral u dv is equal to uv minus integral v du. We have to use this formula if we want to solve any problem by using integration by parts. Don't forget this. Always remember this formula. Whenever we have two products, if we want to integrate those two products, we have to use integration by parts and use this formula to solve that problem. Now, the biggest challenge is choosing u and dv. That's the problem that we have. We have to use u, or we have to use v or dv, but let me show you some techniques. We have a rule called LIATE, L-I-A-T-E, LIATE. We have to use this rule. What do you mean of LIATE? L stands for logarithmic ln x. I stands for inverse trigonometry. Tan inverse. A stands for algebraic. X square. T stands for trigonometry. Sine, bracket sine, sine x, cos x. And E stands for exponential. exponential. Now, if we use this rule, then we will solve integration by part with ease. Choose u from the highest priority in this list. Now let's take example 1. We will solve it step by step. Integral x e x dx. Let's solve our first example step by step. Now, how to solve this one? Mind you, I told you that if we have two products, we can't integrate this one easily. What can we do? We have to use integration by part. Solution. Let u is equal to x. Du is equal to dx. Dv is equal to e raised to the power x. V is equal to e raised to the power x. Now apply the formula. We have to apply the formula. U dv is equal to uv minus integral v du. We have to use this formula to solve this problem. Integral u dv is equal to, what is our u? Our u is x, v is ex minus integral v is ex, du is dx. Now we have used our formula. What next? Minus this one, the integral of ex is the same as ex. This one we cross, the integral become ex plus c. Now we have xex minus ex plus c. We factor e raised to the power x. Or factor e raised to the power x, then we'll be having x minus 1 plus c. This is our final answer. Example 2. Let's look at logarithmic case. Integral ln x dx. How to solve this? This one looks strange because it's only one function. This one only one function. But we can rewrite it. Integral ln x dx is equal to integral ln x times 1 dx. Now we apply the formula now. Let u is equal to ln x. Du is equal to 1 upon x. Dv is equal to dx. V is equal to x. Apply the formula. Integral u dv is equal to uv minus integral v du. There is a formula we have to use to solve this problem. Apply a formula. X ln x minus integral x 1 upon x 1 upon x dx. Now to solve this one, we have x ln x minus x cancel x integral 1 dx. Now we move on. We have x ln x minus the integral of this one become x plus c. This is our final solution to this problem. Let me highlight some common mistakes students make. 1. Wrong choice of u and v. 2. Forgetting minus sign. 3. Not simplifying the integral. 4. Missing constant c. 5. These are common mistakes while solving this problem or using integration by parts to solve this problem. I have to take this one into consideration, so don't forget about these common mistakes. Let's take some exercises. 1. The integral x sine x dx. 2. The integral x squared e raised to the power x dx. Use the rules of integration by part to solve this problem. Practice more problems to master this method. Thank you for watching. Don't forget to subscribe and share.